Now everything is okay?
It's fine. It's fine, sir.
All right. Good morning from here, but good evening for you. So the time here is 8:36 a.m. So I just had my coffee. I know you guys are getting ready for your dinner, um, but this online opportunities are really making us closer, and also allowing us to exchange this technical information that was not possible before. And before I get started, I want to congratulate the organizers for thinking about the theme for this faculty development program. It's sustainable development and practices in geotechnical and geoenvironmental engineering. So the sustainable development and practices is the need of the time, very much needed with what's going on around, what will happen into the future. So everybody working in the geotechnical and geoenvironmental engineering area, they should be rethinking about what they are doing and also thinking about future opportunities on contributing to the sustainable development. So I highly commend the organizers thinking about this futuristic and timely topic for this faculty development program. And I want to particularly thank Dr. Rajiv Kumar, professor in the Department of Civil Engineering at Rajagiri School of Engineering and Technology, for inviting me to be part of this program. I greatly appreciate that. And also, I want to thank Mr. Jay Kumar, assistant professor in civil engineering, who has been nicely coordinating this program. And I want to thank the father for giving that nice introductory comments, and the entire college administration for supporting such activities, and not only educating the own staff and students, but actually educating the faculty across the country and maybe across the world. Um, and I want to congratulate all the participants for taking time to attend this one. I think the time is worth spending because this topic, as I said, is a very, very important topic, and we should all be doing something to this topic. No matter to what extent, even small extent, if you can contribute to this, that can go a long way. As introduced by Rajkumar, so I'm from Chicago. So this is the map of Chicago, and you know where Chicago is. And Chicago is a beautiful place, and especially for infrastructure development and environment. So I welcome you to visit Chicago whenever you come to US. The last two pictures here that shows my campus. It's very close to the downtown, just walking distance. And working in civil engineering and environmental engineering, visiting these kind of places make you very proud of what you can contribute to the society. So as I already mentioned, I work in sustainable engineering and geotechnical and geoenvironmental engineering. My main research focus is on environmental remediation of soil, sediments, groundwater, and stormwater. And this is the topic that has to be addressed by geotechnical and geoenvironmental engineers. I don't see that many people in India working on this topic. So faculty and the students who are on this program, they should start thinking about doing some research on this issue, because this is really a problem worldwide, and India is no exception. And I work on also waste management and landfill engineering. This is another geoenvironmental engineering topic that deals with beneficial use of waste materials, landfills in general, the waste management, what we can do. And this is again is a very growing problem, and everybody has to do something to solve this problem. And then as the program theme, sustainability and resiliency are the most important challenges that we are facing now. And how do we address that in engineering? So this is basically sustainable and resilient engineering. And this can be done in every engineering field. And in particular, geotechnical and geoenvironmental engineering, we don't want to be left behind. We want to be ahead of everybody and do the things that are contributing to sustainability and resiliency. And my background is geotechnical engineering. I did my master's and PhD in geotechnical engineering. I'm familiar with all the geotechnical engineering topics, but all those things that you want to do it, you should do those towards contributing sustainability and resiliency. You need to think differently than what we have been doing in the past. So geotechnical engineering, if you're working on it, so think about how we can incorporate sustainability and resiliency. But if you want to expand your expertise, get into the geoenvironmental engineering. So geoenvironmental engineering deals with this environmental remediation, waste management, and working on those two topics would significantly contribute towards the sustainability and resiliency. So opportunities and challenges and opportunities are there, and it's a matter of how much interest that you have to pursue these things. So just to start with, you want to know what is there to get started. These are the publications that we published in last 25 years. So these are the 4 books. And then we have journal papers and conference papers. And you can access them through my website. So if you are new to this field of geoenvironmental engineering or sustainability and resiliency, then maybe guess the best way is to get hold of some of the publications that you can quickly read and understand the challenges and opportunities. So in our research, in my lab, we do bench scale testing. Of course, we want to identify what is the problem that we want to solve. And we come up with some solution idea, what could be the solution. And then we try to test that research hypothesis through bench scale experiments. Basically, these are small scale experiments that can be easily done in a lab. And then, we also do the scale up experiments, because if you do in a small scale in the lab, that's not representative. So you need to scale up, and again, you can still do that one under controlled conditions in the lab. And then once you understand, fundamentals based on this lab testing, you can incorporate those processes in mathematical modeling. And then you can predict, under different scenarios what could happen, and you can design, even the field systems. So once you design the field system, you may want to go to the field and try it in a small scale to see if what you came up with works or not, because you don't want to implement in a full scale before you know that solution works on a small scale or not. So again, the lab conditions don't represent the field conditions, so you want to go out to the field and try to test under the more realistic field conditions. So if the solution works, then you can recommend that one to be used by professionals. So there are a lot of fundamental advancements that you can make through this research, but ultimate goal should be to develop a practical solution to solve the problem. These days, a lot of researchers are under pressure to publish papers. So the focus of your research should not be, publishing a paper. So we need to be advancing the fundamental knowledge. And then also, we should be trying to solve the real world problem, towards the sustainability and resiliency. I want you to keep this in mind. We all want to publish it. There's no doubt about it. But in that process, we should be advancing the fundamentals, and we should be developing the practical solutions. So this is my lab. I do a lot of experimental research. So we have a soil and material testing equipment. Many of you may have in your soil labs. And geochemical characterization, geochemical testing. If you don't have it in your lab, you may have to team up with other departments on campus, work with them. And the bench scale testing, it depends upon what kind of project that you have, and then you develop the models to use in your research based on the research. So over the last 25 years, I have the pleasure of working with students from all over the world. This picture shows students that I worked with. I tell people that I have the best job in the world, because I work with talented people from all over the world. So it's not only doing research, but learning their culture, learning their you know social aspects. It's a really wonderful experience. So you never get bored in the job that I mean, as a faculty, that I can testify for everyone, because few students will come and go, but you carry those memories and experiences. And a lot of accomplishments that I had, they are all because of the hard work of these students. And as you see here, there are a lot of Indian students who come to my lab and do their PhDs. So coming back to the presentation, I'm going to talk about this. This is a kind of a new topic for you if you are in a geotechnical engineering or geoenvironmental engineering. So geotechnical engineering, I think many of you know already. You work with foundations, retaining structures, tunnels, ground improvement, those kind of things. So those are fine. And on the geoenvironmental side, many of you work on, landfill liners and maybe, reuse of waste materials. But this is another topic that is not explored very well and not done very well in India. And there's a lot of potential to work on. So that's why I wanted to choose this topic for you to, take up on this in the future if you are interested in doing research. So this is a problem of contaminated sites or polluted sites. So if you want to deal with this one, you need to know what is going on now. I think in India, there's, as far as I know, maybe I'm not aware of all the issues there, but I'm going to give you an idea about what is being done in the US. We use the risk-based site remediation, and I'm going to explain that one. So you don't have to start from scratch. You want to see what other people are doing in other countries, and then learn that, and then adopt what is good for your country, your situation. So we have a risk-based site remediation approach in the US that is being practiced for many years, but now we realize that it has some problems. So I'm going to explain what is this risk-based site remediation is and what are the problems. So mainly the problems are we never considered the sustainability and resiliency in developing the site remediation technologies. So that's the new thing that's going to happen now. So not only you have to consider the risk, but you have to consider the sustainability. You need to consider the resiliency when you are trying to come up with a solution for contaminated sites or polluted sites. Sites I mean here is a land like soil or groundwater. So geoenvironmental engineers deal with the soil and groundwater, whereas water and air mostly dealt by environmental engineers. So that's why my presentation topic is risk, sustainability, and resiliency considerations in site remediation. So I'm going to end with a few final remarks at the end. So I want to make it, more general. Now, I may not go into a lot of technical details, but you can find publications if you're interested in more technical details. So the problem of contaminated sites. I mean, so these are the pictures of contaminated sites that you can see at the ground surface. Visually, there are problems that you can see it from here. But many situations, you won't see anything on the ground surface. The ground surface could be very nice, looks normal, but if there's pollution went into the ground, soil is contaminated and groundwater is contaminated, so you have a big issues with that one, right? So it's a hidden problem. If you have a water pollution or air pollution, visually you can see it, but underground contamination of the soils and groundwater is not visible, but it is a huge problem because it can affect the people's health, and also it can affect the ecology and environment surrounding those sites. So this is the problem that geotechnical and geoenvironmental engineers have to deal with. So how do the soils and groundwater gets contaminated? There are many, many sources. If you think about air pollution, right? So in the particulate matter from the air, ultimately they get deposited on the soil and gets mixed with the soil, and when it rains, the contamination gets infiltrated and gets into the groundwater. And infiltration of contaminated surface water. Look at what is going on in industries that generate contaminated liquids, contaminated waste. What are they doing it? A lot of times they put a pond in the back of their industrial plant, and then they just store it there. That eventually will infiltrate into the ground and contaminate the soil and groundwater. And it's not going to stay at the same place, right? When it gets infiltrated into the ground, and especially when it gets into the groundwater, it's going to move with the groundwater, and contamination may spread to larger areas. So if you think you are a mile away from an industrial site, you're going to be free of contamination. That may be wrong. The contamination may be underneath your house, or the location where you are living. So that's the biggest problem. So you can see many other accidental spills. Fertilizers and pesticides used for agricultural purposes. You are looking at improving the crop yield, but these are all nasty chemicals. If they go into the soil and groundwater, they could lead to a lot of problems. Waste dumps is a huge problem in India. You don't have engineered landfills, and a lot of contamination gets into the soil and groundwater, and you have a lot of issues. Mining sites, there are a lot of problems. So if I want to highlight what is the major source of contamination, means this land disposal of solid and liquid waste. So in US we have regulations right now on how to dispose of solid and liquid waste. In the past we didn't have it, and as a result we had a lot of sites, legacy sites, that needs to be cleaned up. So many of these sources. So if you wonder why soils and groundwater gets contaminated, there are many sources that could cause the soil and groundwater contaminated. It's a huge problem in US. We have statistics on number of sites, and the cost estimate on how much it's going to cost to clean up. It's a huge problem. So a lot of sites, and a lot of money is needed. So that's why we are all doing a lot of research on developing new, effective, and less expensive technologies to use to solve these problems. And the problem is, not only these existing sites, more sites are being found every year because of the accidental spills and other, sources. So in the US, we have a good idea about contaminated sites. And in the European Union also, they have a good idea on existing contaminated sites. But also, these contaminated sites exist in developing countries such as Brazil, China, and India, but there is no statistics on those sites, at least publicly not known. But China has taken a big step in trying to clean up contaminated soils, because the contaminated soils are affecting the food chain. So that's an immediate danger to public health. So they have come up with the new law that requires the soils to be cleaned up. And Brazil and India, you have contaminated sites. Those needs to be cleaned up too. So if we have to clean up, what is the way to clean up? What is the approach to clean up? So this is the methodology that we adopt in US. It's called risk-based remedial approach. So let's say you have a potentially contaminated site, so you do the site characterization. So geotechnical and geoenvironmental engineers play a major role in site characterization. So you can get involved in this kind of projects in different ways. So you may not be interested in developing the remediation technology, but you may be interested in doing the site characterization. All the geotechnical site characterization, geophysical site characterization can be, technique can be used here, site characterization. But in addition to that, you need to know, sampling the soils and groundwater and doing the chemical analysis to know the contaminants, okay? So that's the additional knowledge that you need to acquire if you are dealing with contaminated sites. Then if the site is contaminated or not, then you do the risk assessment. This is the important aspect. So I'm going to, expand a little bit on this. Risk assessment is the important thing. So if there is no risk posed by the contamination, then you don't have to do anything. But if there is a risk to humans or the environment, then we need to clean up. So the cleanup does not mean that you have to, take out the contamination entirely, which is not going to be possible. If you spill something into the soil or groundwater, it's very hard to get, every molecule out of the soil and groundwater. So, we have to reduce the contamination to a certain level that it does not pose any problem. So risk will be less than acceptable risk. Then to do that one, so this is where we need to develop different remedial methods. So a lot of research could be done by geotechnical and geoenvironmental engineers to develop the technologies to clean up soils and groundwater. And then you implement it, and then, make the site useful. So the site characterization, I'm not going to talk about it, but I want to talk about this risk assessment, which may be, a new topic for geotechnical and geoenvironmental engineers. But this is extremely important step in addressing the contaminated sites. So in the US, this concept was not there early, and everybody was asked to clean up the site to pristine conditions, make the conditions similar to how it existed before the contamination occurred. But that, as I mentioned, it's impossible, and they spent a lot of money, a lot of time, and they realized that this is not possible. So that's when the risk concept came into existence. So National Research Council or National Academy of Sciences, they did a study and they published this book called Risk Assessment in the Federal Government, Managing the Process. This is for US scenario. And this book is colored red, so it's called Red Book. So Red Book means, it is the book that addresses the risk assessment. So this book made, federal agencies in the U.S. To address the risk assessments, and it also defined a methodology to do the risk assessment. It's a 4-step risk assessment process. So now we pretty much use this as a standard to do the risk assessment. So there's 4 steps are involved in this risk assessment process. So first thing is, the hazard identification. You want to know what chemicals, that you have at your site, which ones are very toxic. That's the, the hazard identification. The exposure assessment is, how much people are going to be, exposed to the contamination. So this is where you need to do the contaminant transport models, and a lot of research that could be done in this area. So the idea is, if you have a contamination, how it is going to be transported, how much is going to get into the, drinking water well, how much people are going to be consuming that. So that's the exposure assessment. And then you have a toxicity assessment. So, how those chemicals are going to be, how much are toxic. So basically, this toxicity assessment is done through animal studies. And you have, chemicals categorized as carcinogens or cancer causing, or non-carcinogen. So you have diseases, but not cancer. So based on those, you can calculate the cancer risk and non-carcinogenic risk. Basically, this is called hazard index. We calculate it. This is a cancer risk. We calculate this one. So this is very important. So this is how you quantify the risk, and then you look at this risk and compare with allowable risk. So hazard index has to be less than 1. If it is more than 1, then you have to treat these non-carcinogenic chemicals. And then if the cancer risk is more than 10 to the power of -6, that is 1 in 1 million, then you have to do the remediation. So this is kind of important step in any site characterization project, is to look at how much is the risk. So this risk assessment, you need to look at, you have a site, right? And then you have to look at, what is the media through which the contamination could be transported. It could be air, it could be soil, it could be groundwater, it could be biota, it could be fish, So then you look at the exposure point where contamination is being exposed to people, in what ways that contamination is being, intaken, uptaken by the people, and then who are the people that are getting exposed to. So you basically, you have a contamination. You really need to know how people, surrounding people, are going to be affected. This is important. For example, you have children right close to the contaminated site. So how much is the effect on children? So this kind of procedure. This procedure can help you understand, risk to children, risk to residents, workers. All these calculations can be done. So that's the very important risk assessment. So if the risk is less than acceptable, then you don't have to do anything, so which is great. But if the risk is more than acceptable, that means you don't want people to be dying, more people to be dying because of this contamination, or the surrounding environment to be degraded as a result of the issues of the contamination. So we need to think about correcting the problem. So we need to do something to address this problem. So what do we do? So that's called remedial goals. You have a contamination concentrations known now, how much contaminant concentrations we should reduce it. Okay. So the risk assessment is, we have contaminant concentrations known, and then we do the exposure assessment and take the toxicity and calculate the risk, right? As I mentioned, that's the risk assessment procedure. So in setting up the remedial goals, we do the backward analysis. So in the backward analysis, what is the allowable risk is. 10 to the power of -6, for example, is cancer risk, or hazard index equal to 1. You can set those numbers. And then you have a toxicity, you have exposure and exposure media. And then you calculate what would be the concentrations here should be. What should be the concentration in the soil and the groundwater should be, so that the risk is equal to the acceptable risk, right? So you're calculating the backward. So in the risk assessment, we use the actual concentrations that are found, but in the backward risk assessment, we find out what would be the concentrations of those chemicals that should be, so that the risk won't be higher. So this basically becomes the remedial goal. So it's a tedious process on how to do this one, but US EPA has simplified the process. They assumed, they made some conservative assumptions, and they calculated what should be the concentrations of different typical contaminants under residential conditions or under commercial industrial conditions. Okay? So you can find these concentrations and compare with the concentrations that you have in the site. So risk assessment became very, very simple now, because they did all this analysis for you. You don't have to do complicated calculations about risk assessment. So what you have to do is you have to go to this US EPA website, and they look at these concentrations of different chemicals, and then compare with the concentrations of soil and groundwater from your site characterization, and then you compare that. So if the concentrations are less than these are called regional screening levels, then you are fine. So risk is less than acceptable risk. So if it is more, then risk is not acceptable. So maybe some chemicals are less than the allowable limits or screening levels. Some chemicals may be higher than the screening levels. So then those chemicals that are exceeding the screening levels, those become your target chemicals for remediation. So your goal should be reducing those chemicals to the concentrations, to the levels of the screening levels. So you're not trying to reduce to 0 levels, but you're trying to reduce to this RSM level. So that's the approach we do this. So risk assessment is very, very important. Even like people do research on remediation, they try to remove everything. So you don't need to remove everything from the soil. You don't have to remove everything from the groundwater. So you need to reduce the concentrations to the risk-based levels. So that's very important to remember. So those risk-based levels are called remediation goals. So then question is, what technologies that we can use to reduce the concentrations to these remedial goals? So there are many different remediation technologies, okay? I teach a course now. I'm teaching now. I've been teaching this course for many years. It's called Environmental Remediation Engineering, and we talk about all these different technologies. So monitor natural attenuation, containment, and the different remediation technologies. So monitor natural attenuation is, naturally there's existing microbial conditions that can degrade the contamination. Try to monitor that. Containment could be, taking out the contaminated soils, putting in the landfills or impoundments, or in situ containment could be, passive systems, horizontal barriers, vertical barriers, and caps, or active systems for groundwater pumping and subsurface drains. Otherwise, you can do the treatment or remediation. This could have ex situ methods and in situ methods. So if you have a soil that is contaminated, and you want to treat it in ground without excavating the soil out of the ground, then there are different technologies. So there could be physical chemical based methods or thermal based methods or biological methods. So these are all the different technologies that are there. So it's nice to know, which technologies will be applicable for, soil conditions that you have, contamination conditions that you have. So these are all, like, a lot of studies are done in this on these technologies. But if you are interested in, you look at what kind of contaminated sites that you have, contaminated soils you have, contaminants that you have. Maybe you can see which technologies are applicable for your site. So you can undertake the research. So it may not be like developing a new technology, but evaluating if any of these technologies are suitable for your site or not. So in the biological methods, you have a bioremediation, bioventing, phytoremediation. So and then, if you don't want to, treat it in ground, maybe you can excavate the soil and treat it above ground. So some modifications of these in situ methods can be considered as ex situ methods, and these are all the ex situ methods that you can use to clean up the soils. At least, a lot of research has been done on these technologies. A lot of information is there, and if you are interested in, evaluating any of this technology, that could be a master's thesis, for students. So and then, if the contamination, infiltrated from data zone into the groundwater, and now groundwater is contaminated, and its contamination plume is there and it's migrating, there are different technologies developed to treat the contaminated groundwater. So remember, we don't have one technology. You really have to have different technologies because site conditions vary, right? You have different types of soils, different types of contaminants. So you have to match that soil conditions with the technology. So we have these technologies that have been researched. Some of these technologies have been used at sites in the US. So I highly recommend you to, get hold of, some publication like this book that talks about all these different technologies in an easy way. You don't have to spend a lot of time, but try to see if you can, ask your library to get a copy of this book, and then get hold of this book and then read about these different technologies and see which technologies could be useful for your situation, and try to investigate those technologies. So then you design and implement. That's what happens. So a lot of projects, a lot of this remediation is being done this way. And we have been using this approach for a long time, but now we are realizing that we have some problems with this methodology. So currently we are focused on reducing the contaminant concentrations to risk-based levels, right? So we are eliminating the risk to public health and the environment. That's our utmost, important goal, no doubt about it. And then if it can be done by different technologies, so we look at, which technology is easy to implement, which technology costs less, which technology takes less time, right? So these are the considerations right now to, look at the remediation. But in the context of sustainability, we are not looking at that big picture when we look at the remediation of contaminated sites. So we're not looking at how much energy is used for, implementing that technology. What are the air emissions that are associated with implementing the technology? You're trying to clean up, but are you going to create any secondary waste? What kind of natural resources that are you going to use it? So we are laser focused on reducing the concentrations right now. We don't care about all these things. But in the context of sustainability, we should be reducing the concentrations of the contaminants at our site while considering these aspects. So we need to, use the technology that uses less energy, where, produces, less air emissions, reduces the less secondary waste. So all this, and uses the less natural resources. From sustainability point of view, these are extremely important. So we need to look at it. Yeah, we're trying to reduce the concentrations in the soil. Maybe this contamination is lead. Let's say lead concentrations. We want to reduce it, but in the process, if we are emitting all these air emissions, it's not good. So what are we? What is the net environmental benefit of what we are doing? Looking at a little bit holistically, and is it sustainable? So that's the question. So now, people are thinking about whatever the remediation that we want to do it, we want to do it in a green manner and sustainable manner. So this concept of green and sustainable remediation has emerged. So the definition of green and sustainable remediation is, I highlighted, this is a long definition, but we want to mitigate the contaminant risk to receptors. That's our ultimate goal of remediation. So that has been the goal of remediation. So we're not compromising that one. But, we are adding, some additional constraints on how it should be done. We need to balance community goals, basically like the social aspects, economic impacts, how much, indirect and indirect impacts, and these broader environmental impacts, like, air emissions or carbon footprint, those kind of things. So these additional considerations would make the remediation more sustainable. So again, just the definition to mention again, our primary goal is to reduce the contamination to the risk-based levels to protect the public health and the environment. That's our primary goal. So again, that has been the practice. But now we are adding these additional requirements. Let's do that one, considering the environmental, social, and economic aspects. So we need to really balance these two aspects. We need to accomplish both of them at the same time. So that's the concept about incorporating the sustainability in remediation. So how do we do this now? So that flow chart that I showed you before, it's kind of the same thing. You do the site characterization, and you do the risk assessment, establish the remedial goals, and find what are the potential remediation technologies. And then before, we were using one of these technologies based on the cost, based on the ease of implementation. But instead of that, we need to be doing this sustainability assessment. This is kind of a new thing, new step involved in this, methodology. So we need to be, we have potential remediation technologies. You do some preliminary design of them and subject them to the sustainability assessment to quantify the sustainability of each of those technologies and see which one is more sustainable and select that, sustainable remediation technology. So that if you do that one, you are, reaching your remedial goals, and at the same time, you are achieving the sustainability. So you are basically selecting a sustainable remediation method, and then use that one to implement and achieve the remediation. So one of the challenging aspects of doing this extra task of sustainability assessment is, how do we assess it? How do we assess the sustainability? How do we quantify the sustainability? A lot of people talk about sustainability, right? And, in a general terms, but quantifying the sustainability is extremely important. Then you can see, as an engineer, you want to have the numbers to, see how sustainable your system is. So we need to, have tools to assess the sustainability, quantify the sustainability. So there are different tools to assess the sustainability of remediation systems. So you can, maybe just use the best management practices. There could be qualitative assessment tools, semi-quantitative assessment tools, or quantitative assessment tools. These are there. And I can go into details of all these things, but I will show you a reference where you can find out more information about these things. But the one which I like the most is this life cycle sustainability assessment. So it's a very comprehensive approach. It's based on the triple bottom line aspects, environmental, economic, and social, and it takes into account of the life cycle. So I highly recommend using this life cycle sustainability assessment. So just briefly, what is this one? what is this life cycle sustainability assessment, triple bottom line assessment. So what I'm trying to say is, so we have a primary aim of reducing the concentrations to meet the risk-based levels. But in addition to that, we should be looking at the sustainability. In the sustainability, we are looking at the broader environmental impacts. So we should be looking at these kind of indicators. What is the greenhouse gas emissions? What is the air pollution? How much is the energy is needed? What is the water usage, natural resources, waste generation? So these are all, we should be able to quantify those numbers. And then we should be also looking at the economics. A lot of times we know the direct costs, but we should be spending a little bit more time on looking at indirect costs and benefits, which we don't do it in a regular way, in a regular project. And more importantly, we should be looking at the social aspects, how this project is going to benefit the people living around that area or community around that area, how these people's economic situation is going to be improved, or how the environmental aspects of the community are going to be improved. So these social aspects are new to engineers. I mean, we don't consider these social aspects in any of our courses that we teach, but it's becoming, from sustainability point of view, you want to have the social aspects as important as economic aspects, as important as environmental aspects. So the most important part in sustainability assessment is to define these indicators, and you need to have a tools to calculate them as their metrics. So you cannot really have an indicator that cannot be quantified in a quantitative way. So it should be represented by the numbers. So that's the important thing that you want to look at it. So then, as I said, life cycle is another important concept that people in engineering in general and in geotechnical engineering in particular, we don't really worry about it. We design foundations, we design head retaining systems, and we think that contractor will bring the materials and construct it, and that's what we think about it. But in sustainability assessment, we need to think about this life cycle thinking. So you need to think about the whole process, starting from raw material acquisition. So starting from mining, what materials that are needed to manufacture the materials that you're going to use it. For example, if I'm using cement and concrete, cement or steel, so what materials are needed, to the steel plant? What materials are needed for the concrete plant? Or if you are using geosynthetics, what kind of materials I need for manufacturing of those geosynthetics. And then manufacturing of those materials itself, right? When you're making the cement, the process emits a lot of greenhouse gases and air pollution, all those things. So materials manufacturing is important. And then transportation of those materials. And then in case of remediation, you're going to remediation implementation and monitoring. And then at the end, do you need to have these reuse and disposal site use? So you need to look at that aspect. So we need to consider these triple bottom line aspects at every life cycle stage of your project, which we don't do it. A lot of times we just design it and think about construction, right? So which is not good from sustainability point of view. If you want to really look at the sustainability, we should be looking at cradle to grave, the concept in life cycle assessments. So we quantify those indicators, environmental, economic, and social indicators. So you get all these numbers. You have a long list of these indicators with values. Then how do you make a decision, right? And you won't see one option having all good numbers and other option having bad numbers. So a lot of times you will have a mixed results. So how do you make a decision based on these different aspects and reflecting different trends? So that's when we need a multi-criteria decision analysis, and maybe we can calculate using that kind of approach sustainability index, basically considering all the aspects, how sustainable is your system. So that's where we developed a new tool called Polluted, and that's what we do it here. So we use the analytical hierarchy process if we need to weigh in, apply the weightages to different aspects. And then we use multi-criteria decision analysis to convert, these different indicators with different units into normalized values. and we finally calculate a sustainability index. So I have a publication on this one, so you can see more details on how this can be applied. Okay. So how do we apply? Let's say I have a site. I just want to give you a quick example of how this can be applied. So this is a site that we have. Soil is contaminated. It's a clayey type soil, and it's contaminated with organic contaminants and then metals. And the sources of contamination for this site, are listed here. So basically, the industrial site, and now it doesn't exist. Now it's all demolished, but the soils are contaminated, and they plan to build a high school at this site. So think about it. And you want to be very concerned about this existing contamination. So the remediation is important because the children are going to be there all the time. So based on potential technologies that could be applicable. So you have types of soils, you have type of contaminants, you have the site characterization data, and based on all those things, you have this, all these different remediation technologies that are available, and which technologies could be applicable for this site. So, in this situation, we found out that these three technologies can be used to solve the problem: electrokinetic remediation, excavation and disposal, and phytoremediation. So these are the technologies that could be, reduce the concentrations or reduce the risk to the acceptable level. So in now current practice is to, whichever the owner and the engineers decide to use it, and they use it. But what we are saying is, let's go one step further and do the sustainability assessment and see which one is sustainable. So based on the sustainability assessment, considers all those broader impacts, right? Environmental, economic, and social impacts. If you go through that framework that I mentioned, you can calculate the sustainability index of all this: electrokinetic remediation, excavation and disposal, and phytoremediation. So higher the sustainability index, better the technology is. So here you can see, first, preferred choice would be phytoremediation, where you use the plants to clean up the contamination. Then the second one is electrokinetic remediation, and the third option is excavation and disposal. So if I'm looking at doing that, the job of reducing the risk, but phytoremediation can do it in a more sustainable way. So that's how we apply this framework and then decide on the sustainable remediation. So if you are more, there is a lot of scope to work in this area. So if you are interested in knowing more details about this one, I highly recommend you to get hold of this book and read about it. It's very easy to read. And if you have any questions, feel free to contact me. So that's sustainability. I just want to get to the last part of my presentation. Impacts of climate change. I don't want to, say the importance of this one, because all the people in Kerala are feeling the impacts as we speak, right? You have been having these rains and, landslides and houses washing away. It's sad to see those videos on TV, on social media. So no doubt they're all attributed to climate change. What is the climate change? It's due to greenhouse gases. The greenhouse gases are the main reason why we have this global warming and global climate change. So as you see, the data shows that, these greenhouse gases, basically carbon dioxide, methane, nitrous oxide, have been increasing significantly. There is no downward trend. These are all going up. As a result of that, global temperatures have been changing. And as a result of that, we are seeing, and these changes are not uniform across the planet. Some places, you don't have any water. It's a drought. Some places you have a lot of water, flooding, a lot of hurricanes, and a lot of wildfires, and a lot of air pollution, a lot of hunger and the scarcity of food. So, these impacts are being felt more and more as we, go into the future. These were not happening before, but these have been increasing into the future. So, if we consider the sustainable, so here these just to show that, these things are increasing significantly. So we really need to do something about this one. The climate change impacts, as I said, the temperature, and the precipitation and wind and wildfires. So these are, happening in a way that you are not used to it, no matter where you are living. So, if you say that, you are not feeling these changes, you're not on this planet Earth, you're somewhere else in a different planet. So everybody is feeling the impacts of climate change in terms of the temperature, precipitation, or wind issues, hurricane, tornadoes, storm surge issues, and wildfires issues. Some places, some of these are more prevalent, and other places, others are more prevalent. So this is not a fiction, guys. And so this is what is happening. And, as engineers, we really need to do something. So the climate change can affect the contaminants too. So if we are talking about just specifically, contamination sites, so the toxicity of the contamination could be impacted. The exposure could be impacted. Sensitivity of, organisms could be impacted. Transport and fate of the contaminants could be impacted. Efficacy of the technologies could be impacted. So, all these things are going to be impacted. So, for example, you could be having a decreasing pH, then, some of the metals could be more released, so toxicity could be increased, and some, species could be more sensitive to pH. Increasing temperature could increase the toxicity, decrease the dissolved oxygen, and, you will have associated problems. Altered precipitation patterns, wetter, drier. So those things could impact, extreme weather, wetter or drier. Human response to climate change could be, different too. So the toxicity of the contamination could be, impacted by climate change. And, the climate change can undermine the remediation. So you're designing remediation thinking that conditions would be typical, but it's not. So you designed a remediation system, and suddenly you are having all this heavy rainfall events. So you haven't considered those aspects in your design. So there's a lot of flooding happens. Whatever your remediation that you have done it, that's going to be washed away. So you may not be getting the remediation that you need. The soil may not be remediated, or contamination. You thought contamination in the particular area with the flooding and all the issues, contamination may be spreading. Or if you have a drought, then you may have oxidation of soils. Then you don't have water for the treatment. So a sea level rise, you could have erosion. Site could be inundated with water. Extreme weather, you could have a scouring, flooding. Extreme heat could be a problem, and fire. So if what is happening is some of the remediation that is done in the past, now people are going back to the sites and trying to address these issues. So I will show you an example of one of those cases, but we have designed some of the remediation systems. They are ongoing, but the problem is, they're not designed for these climate impacts, and we need to, change those things. For example, soil treatment. If you have a bioremediation, then bacterial activity could change, depending upon the conditions that you have. Let's say you have a lot of infiltration, a lot of wetter conditions, land forming and land spreading, flooding issues. Groundwater treatment, if you're trying to groundwater, so there could be differences in recharge and extraction, just because of your groundwater level fluctuations. And the removal of contaminated material, so with the flooding, you may be just spreading all the contaminated material all around in your neighborhood. And so engineered in situ systems, soil flushing, you may have excess water or insufficient water. Soil extraction, warmer temperatures may help, but colder temperatures may not help. Natural attenuation, how it's going to be affected. Incineration, how it's going to be affected. So there are a lot of issues that could affect the remediation. So the bottom line is we cannot ignore these impacts. So we have to do something. So what can we do it? So now we engineers are challenged to do one additional thing in addition to sustainability, is to think about designing for the changing climate, right? So again, our goal is to reduce the risk to public health, but we want to do it in a sustainable manner. We saw that one before, but now we are challenged to do, to address the climate change impacts. That means we need to make our remediation be resilient. So there are different definitions for resilience, but the one I like it is the one which is given by NRC, the ability to prepare and plan for, absorb, recover from, and more successfully adapt to adverse events. So this is kind of a general definition that you can apply to any engineering project that you're working on, and it's equally applicable for a remediation project. So in the resilient site remediation, what we want to do is we want to remediate such a way that, if some extreme event happens, like for example, what is going on now in Kerala, if a lot of flooding happens, the remediation maybe, the performance could be compromised. But when the flood recedes, then, that should come back to, the performance that is acceptable, or, the performance could be same as what it was before or even better than before. So what we are trying to say is you design a system such that it could compromise the performance temporarily during that climate impact event. But then when that climate impact goes away, then it can come back and then perform as good as it was before. So we need to think about this one. To make this one happen, we need to think differently. So we need to really think, totally in a unconventional way than what we have been doing. So how do we do it? So what we do is we look at, we do the vulnerability assessment. In the vulnerability assessment, you look at what is the exposure. This is the exposure. So in some situations, for example, in Kerala, you have flooding. But let's say here in US, in California, we have wildfires. So what kind of, climate impact that you're going to, face? It could be one impact or it could be multiple impacts. You look at that one. And under those impacts, how your system is going to perform, how your system is going to be compromised. And then if the system is compromising it, then you identify what options that you have to address that, adapt to that situation, so you don't lose the performance. And then you implement that the adaptive measure, and then you keep monitoring, because these impacts are, I know there are predictions of what happens with time. You can use the models and see how the flooding scenarios are going to be in Kerala into the future. But those are global models. There are a lot of uncertainties. So what we do is we need to have a monitoring system. So every year, see how these climate impacts are happening, and then see our adaptive strategies, should they be changed or not. So this vulnerability evaluation is one important task that we have to do it. There are some tools which can be used to assess, as I said, flooding or surge or sea level rise, and based on that, you have to look at adaptive strategies to address those things. So just want to help you understand what can be done, I want to give you a couple of examples. For example, this is a contaminated site. This is Hawaii. Hawaii has a lot of these islands, and at one of the islands, they found that the some part of that island beach sand is contaminated with pesticides. And you look at that, this site is very inaccessible, so it's in the middle of the ocean. But the contamination is posing high risk, not to people, because people may not be living there, but there are a lot of these ecologically sensitive birds that are there. So you want to make sure that they don't become extinct. So what is the solution for this one, right? With the sea level rise, with a lot of uncertain surge, so no matter what you do, you don't know if that is going to perform or not. So the best strategy they found out, is to, dig out that contaminated sand and take it out from the island completely. So that's the only resilient solution to the problem, because there is no other way that would be possible to keep the contamination exposure to these birds. So this complete removal is an option. Now let me show you another site where this is the site which is contaminated with creosote, which is a problem, highly toxic. And so they did the capping of the sediments here, and with the sea level rise, with the surge, that capping is going to get destroyed. It's not going to function. So what they are doing now is to address that issue. They're putting a sheet pile wall. You can see the picture on the bottom right. So they're putting the sheet pile wall so that it can control the sea level rise and the surge, so that the other side you have a cap to the sediments are not impacted. So again, this is what being done to address the climate impacts. This is another case study. This is a landfill that is existing right next to an harbor, and with the climate change, the water level is going to be expected to increase, and surge is going to be high. So what they are doing is they're not waiting for things to get worse. So they are actually, retrofitting the edges of that landfill site with this kind of system. So you can see there is a wetland. There is basically this is almost like a seawall. And so, this is a harbor site. If the water level goes up, this is the left side is the landfill. And if this was not there, if the water level rises or surge comes up, then all the waste would have come into the water and could have made huge mess. But as a precautionary for these climate impacts, they know that climate impacts are going to happen. So they have constructed this stuff so that the waste is contained properly. And this is another situation where this site is remediated, but there's a danger of this site getting inundated and could make the site worse. So they are looking at putting this barrier systems into the ocean. So if you look at this one here, and so that will prevent the surge and then protect the so now the methodology, the framework to look at the contaminated site remediation has become a little bit more comprehensive. So what is there? So site characterization is the same thing. Risk assessment is the same thing, and identify the different potential remediation technologies to reduce the concentrations to the risk levels. That's the same thing that we have been doing. Now we are introducing this new thing called, the vulnerability assessment and climate adaptation. So you look at these potential technologies and see which one can resist the flooding situation, or wildfire situation, or sea level rise. So that assessment, we were not doing it before. Now we have to do that one as an extra step. And once we do that one, and from here we look at, out of the potential technologies, we find out the resilient technologies. Once you find out the resilient technologies, then you want to do the sustainability assessment, like what I showed you before, like the colleagues. So basically, you are eliminating some of the options here because they may not be resilient. And also, you are integrating some resilient adaptive measures in there. And then consider those aspects in your sustainability assessment, like what we have done before, like a quantitative sustainability assessment, like a triple bottom line life cycle. And then if you select out of those resilient options, the sustainable option now you have is sustainable and resilient remedial option that you can implement. So that's going to be resilient and it's going to be sustainable. So the way I wrote a paper on this one, you can find more information about that one. So we're adding two different things for the current practice. One is addressing the resiliency, other one is looking at the sustainability. So this is very important. So risk is to protect the public and the environment, that we cannot compromise, but we must address the resiliency because of the climate change impacts, such as flooding. if you don't consider that one, whatever you do is going to go waste. And then in the long run, we need to look at the sustainability. So sustainability, includes reduction of the greenhouse gases. The reduction of greenhouse gases is the main, mitigation technique for climate impacts. If you want to reduce the climate impacts, so you need to be, embarking on the sustainability aspects and reducing the greenhouse gases. That is the source of our climate change. So in the broader sense, sustainability is the one which we should be hoping for. And but the time it takes for reducing the greenhouse gases is going to, be long. But meanwhile, we really need to look into the, coping up with the climate impacts. That's the resiliency. So basically, we need to think about resiliency as a temporary measure, sustainability as a long-term measure. All the time, we are looking after protecting the public and the environment. So just this is my final slide. Just reflect on what I mentioned. So risk-based remediation approach is the rational approach that we follow. There's no problems with that one. We have to follow that. And in India, I suggest you should look into how it is done now. Can you incorporate the risk in the remedial decisions? I want you to do that. And then we need to add on sustainability and resiliency. So these are the challenging things. Kind of headaches if you want to think about it, but there are opportunities for us to do something innovative to come up with a sustainable and resilient remediation technologies. And we need to quantify the sustainability. As I mentioned, you might have heard about a lot of talks about sustainability. So I'm really sick of hearing the word sustainability. You don't want people to keep preaching how important is the sustainability, but you want them to show you what they are doing is sustainable through this quantitative framework. So show me the numbers. You say sustainable. So how would I know? Show me the numbers. So that's why these sustainability assessment frameworks are extremely important. And climate change impacts and vulnerability, we cannot take them for granted. We are going to face these challenges in the future, and whatever we do, not only in the remediation field, but in other situations also, we need to look at these things. So if you are interested in the sustainability and resiliency, I highly recommend you to get hold of this book. As I said, individually, you may not be able to afford this book, but you can ask your library to get a copy of this book, and you get a chance to go through this thing, and you can understand the importance of sustainability, resiliency, and quantitative framework, risk management practices, and some examples on how to do this one. So I also want to mention that the geoenvironmental engineering is an evolving field, and a lot of work has been done in the US and the European Union, but not much is done in India. There's a lot of scope for this. I organize weekly webinars. I want you to note down this address, and you can go there and find the information. You can attend these webinars on generally on Fridays at 7:30 p.m. or some occasions at a different time. You can ask questions to the speaker live. But if not, you can go to this YouTube channel. There are now, I think, more than 45 webinars recorded. I mean, these are all like highly technical. If you go to a major conference, there will be like a main speaker giving the plenary presentation. We are like that one. So speakers allowed me to record this one, which is kind of nice. So you may find an interesting topic out of all these 40 or 45 webinars that are recorded. And also, if your students are looking for some projects, so you can ask them to view these videos and say, hey, which topic you're interested in, and what can you do with that one? You can challenge the students with this one. So with that one, this is my contact information. I would be very happy to, answer any questions that you have, if not now, but, in the future through the emails. And you can look at these websites for those publications and all additional information. So with that one, I want to thank the organizers again for giving me the opportunity to present. And I want to again congratulate all the participants for taking this course and enlightening, about emerging issues and what, as an engineers, we can do it. And this is a faculty development program, so many of you are faculty, and we should be teaching our students about these issues, and that's how we can, make more people educated. So we are in a noble profession where we can make huge difference in people. So with that one, I want to end my presentation, and I will be happy to take any questions that you have, or if you have, sorry, I took time, but if you have, you don't have time, you can always ask me questions later.